There is a planet in our own solar system where it rains diamonds. Another one smells like rotten eggs and rains glass sideways at 5,000 miles an hour. A third is hotter than most stars in the sky, hot enough to rip hydrogen molecules apart before they can even form. We have found thousands of planets beyond our solar system, and one thing keeps showing up. Almost none of them have anywhere to stand. No ground, no floor. Just gas, pressure, and heat that would erase anything we sent into it in seconds. This is every planet in our solar system and beyond it that a spacecraft could never survive landing on, and the reasons why get stranger the further out you go. Jupiter, planet with no floor. Jupiter is the largest planet in the solar system, more than twice the mass of every other planet combined. And it has no surface at all. It should have something. A planet this massive, this old, feels like it ought to have a floor somewhere underneath the clouds. It doesn't. Jupiter is gas from the top of its atmosphere all the way down, mostly hydrogen and helium, and the deeper you go, the worse it gets. Pressure and temperature climb so fast that any spacecraft entering would be crushed, melted, and vaporized long before reaching anything solid. NASA's Galileo probe tested this directly in 1995, dropping straight into the atmosphere to measure what was down there. It survived less than an hour, transmitting data the whole way down, before the pressure destroyed it completely. Deeper, at pressure so extreme that carbon compounds get squeezed into crystal form, scientists believe it actually rains diamonds, falling endlessly through a planet no one will ever retrieve them from. On top of all that, Jupiter's Great Red Spot, a storm wider than Earth itself, has been raging continuously for at least 190 years, with no sign of slowing down. Galileo's instruments recorded winds over 400 kilometers an hour and lightning bolts hundreds of times, more powerful than anything ever recorded on Earth on the way down, right up until the signal cut out. We have orbited Jupiter, flown past it, and sent a probe straight into it. We still don't know for certain what, if anything, exists at its center, or whether center even means anything on a planet built entirely out of gas, compressed hydrogen, and pressure that behaves more like a fluid than a solid the deeper it goes. But Jupiter isn't the only planet next door hiding a death sentence behind a pretty color. Venus, Earth's twin. Venus is almost the same size as Earth, similar mass, similar rock, formed from roughly the same material at roughly the same distance from the sun. By every measure that matters for building a planet, it should be our closest cousin. Instead, its surface sits at 872 Fahrenheit, hot enough to melt lead, under atmospheric pressure 92 times stronger than Earth's, the same crushing force you'd feel nearly a kilometer underwater. The Soviet Union tried landing there anyway. Between the 1970s and 1980s, several Venera landers made it all the way to the surface and functioned for barely an hour before the heat and pressure destroyed them, one managing to send back the only photographs we have ever taken from the ground. Above all that, Venus is wrapped in clouds of concentrated sulfuric acid, meaning anything descending has to survive corrosive rain before it even reaches the heat waiting below. Scientists still don't fully agree on why Venus, built almost identically to Earth, tipped into a runaway greenhouse effect this extreme while our planet didn't. And some researchers suggest Venus may have had oceans for billions of years before losing them entirely as its greenhouse effect spiraled out of control. Other researchers argue Venus may never have had liquid water at all, and the two camps still haven't settled it. The planet that shows what happens when habitable goes wrong is right next to the one that we know can support life. We still don't fully understand when it tipped over the edge. If Venus feels extreme, it's still nothing compared to what's floating around other stars entirely. Planet that rains glass. 64 light years away sits a gas giant that looks, from a distance, like a deep blue marble, almost like Earth. It is not like Earth. Its daytime temperature reaches over 1652 degrees Fahrenheit, and winds tear through its atmosphere at roughly 8,000 kilometers an hour, about 7 times the speed of sound, among the fastest winds ever measured on any planet. That heat is enough to vaporize silicate rock straight into glass, and those same winds carry the vapor sideways around the entire planet before it cools and falls, not down, but horizontally, as molten glass rains. NASA's own description of the planet calls it a world where getting caught in the weather means death by 1,000 cuts. In 2024, new James Webb Space Telescope data added one more detail nobody expected. The atmosphere carries hydrogen sulfide, the same compound responsible for the smell of rotten eggs, discovered while researchers were specifically checking for methane and finding none at all. The blue color that once made astronomers briefly compare this world to Earth turned out to have nothing to do with oceans. It's a hazy, blowtorch sky, scattering light the same way ours does, on a planet engineered by its own physics to destroy anything that came near it. Earlier observations from Chandra and XMM Newton also found the planet's outer atmosphere is far larger than expected, bleeding away into space at a rate of hundreds of millions of pounds a second under constant bombardment from its star. And if glass rain sounds bad, one planet figured out how to do the exact same thing with metal. WASP-76b, where it rains iron. WASP-76b orbits so close to its star that one side is permanently locked facing it, sitting roughly 30 million miles out, about a twelfth of the distance between Mercury and our own sun. That permanent day side reaches over 4,352 degrees Fahrenheit, hot enough to vaporize iron straight out of solid rock. The planet's winds then carry that iron vapor around to the cooler night side, where temperatures drop enough for it to condense back into liquid metal and fall as rain, actual molten iron, out of the sky. In 2024, the European Space Agency's CHEOPS telescope caught something even stranger here. A faint rainbow-like glow called a glory effect, a phenomenon that had only ever been confirmed on Earth and, once, on Venus, now showing up on a planet where the rain is metal. It took 23 separate observations over 3 years to confirm the signal was real. Nobody expected the same delicate optical trick that produces rainbows on Earth to survive weather this violent, on a world hundreds of light years away that vaporizes rock for a living. WASP-76b proves a planet can be scientifically beautiful and completely unsurvivable in the exact same breath. Its night side still sits above 2,372 degrees Fahrenheit, meaning there is no cool refuge anywhere on the planet, only a difference between deadly and slightly less deadly. Iron rain sounds like the ceiling of what a planet can throw at you. It isn't. Kelt 9b, hotter than stars. Kelt 9b holds a record that shouldn't belong to a planet at all. Its dayside temperature reaches roughly 7,772 degrees Fahrenheit, hotter than the surface of most stars visible in the night sky, including many stars smaller than our own sun. At that temperature, hydrogen molecules in its atmosphere don't just heat up, they're torn apart into individual atoms before they even have a chance to recombine into anything stable. The planet orbits its star in under a day and a half, close enough that stellar radiation is actively stripping its atmosphere away, leaving behind what astronomers describe as a comet-like tail of escaping gas trailing behind the planet as it orbits. Kelt 9b is technically a gas giant, meaning it shares Jupiter's problem of having no solid surface anywhere, but it stacks a second, worse problem directly on top of that, an atmosphere that's being actively erased by its own star, every single day it exists. It isn't just a planet with no floor to land on. It's a planet that may not fully exist in its current form a few billion years from now. Some researchers believe Kelt 9b could eventually be stripped down to a bare rocky core, assuming it survives its own star long enough to get there. After a planet hot enough to outglow stars, it feels strange to end this list on something Earth-sized. But size was never the problem. 55 Cancri E, the diamond planet. 55 Cancri E is close to Earth's size, roughly twice the diameter, which on paper should make it one of the more familiar, more relatable worlds on this entire list. It orbits its star in just 18 hours, so close and so tidally locked that its permanent dayside sits around 4,172 degrees Fahrenheit, hot enough to keep exposed rock in a constant molten state rather than ever cooling into a solid crust. Scientists studying the planet believe the entire dayside may be covered by an ocean of lava rather than solid ground, with rock cycling between molten and vapor states depending on the time of its brutally short day. What makes 55 Cancri E stranger is what might be happening underneath. Given the planet's measured density and the unusually carbon-rich chemistry of its star system, some researchers believe its interior could be dense with crystallized carbon, meaning a meaningful fraction of a planet close to Earth's size might genuinely be made of diamond, sealed under a surface no lander could ever reach intact. Some researchers have pushed back on the diamond theory entirely, arguing the planet's chemistry may be closer to Earth's than first thought, and the debate is still unresolved. It's the one planet on this list built roughly like ours. And it's still nothing but molten rock, crushing heat, and possibly buried diamond the entire way down, with scientists genuinely divided on which version of this planet is the real one. A gas giant with no floor at all, a twin of Earth cooked into a furnace, worlds that rain glass, then iron, one hotter than the stars it orbits near, and one built from lava sitting on top of diamond. Size, distance, and familiarity turned out to mean nothing. What actually decides whether a planet can be stood on has almost nothing to do with how much it resembles home. If one of these worlds stuck with you, subscribe, because we're going to keep finding the places in this universe that were never built for us to visit.